Hello and welcome to this presentation video on our low carbon networks funded project Respond. My name's Andy Howard and I am the Respond project manager. The purpose of the presentation is to explain the Respond project and the new fault current limiting service to industrial and commercial electricity customers. To provide an introduction and background, electricity has historically been generated from large power stations, predominantly from fossil fuels. But in the low carbon future, as we reduce our dependence on these fuels, we will use much more electricity and the way we manage our network will need to change. We expect our customers to connect new devices to the network, such as heat pumps, electric vehicles, solar panels, and their own local generation, such as wind turbines or combined heat and power plants. This will also bring new challenges for us and how we manage our network when faults occur. When a fault occurs on the network, there is a sudden surge of current, much larger than our normal load current, like when water flows when there's a burst on a water pipe. This flow of current is known as fault current and can damage our network if it's too large. In a low carbon future, this fault current will increase because of the amount of new low carbon technologies being connected locally to our network. The Respond project provides an alternative approach to managing fault level, which is the maximum amount of fault current that can flow. Respond uses a combination of innovative new technology and commercial techniques to achieve this, which is more cost effective than our traditional replacement approach. The commercial technique offers financial benefits to customers taking part and is known as the fault current limiting service. To reduce the fault level, we need to reduce the sources of fault current which can be generated. Generators are an obvious source, but motors that usually consume electricity can become generators during a fault. This is because of the natural relationship between electricity, magnetism and motion. The magnitude of the fault current that flows depends upon the size of the generator or motor and the distance away from the point of fault. In the future, as there will be more local generation on our network close to the point of fault, there will be an increase in the potential fault current or fault level, and this is what we need to manage. To elaborate on the problem we face, here is a simplified version of how our network operates at the moment. Electricity is generated by power stations around the country connected to the national grid. From the national grid, it flows down to the local distribution network operators like ourselves at Electricity North West. Electricity is then distributed by us to homes and businesses through a network of smaller substations, overhead lines and underground cables. In this example, you can see domestic customers and businesses on the right of the diagram and a customer with a combined heat and power plant on the left. This is a large customer and it has its own private electrical network designed to supply lighting, heating and other general usages around the site. It also has a large motor and a combined heat and power generator or CHP unit. This unit can supply electricity both for the customer and it may also export electricity back onto our network. We have shown each part of the customer's network protected by a circuit breaker or similar device. When a fault occurs, fault current from all the connected sources of generation, including the customer's generator and motor, surges towards the point of fault on our network. This is similar to the flow of water you experience when the water pipe is burst. You can see in this example the dial at our substation has moved from green to amber. This indicates the change from load current to fault current, but fault current at a level that is still safe and can be managed by our network equipment. The circuit breaker operates, isolating the fault from all the sources of electricity. The customers on the right of the diagram go off supply. As the fault is cleared, the meter drops back to green, normal load current. The customers on the rest of the network remain on supply during the fault and are largely unaffected by it. In the future, as the number of low-carbon technologies on the network increases, particularly the number of generators, the circuit breaker in this example will need to deal with an increased amount of fault current. As the amount of potential fault current increases, the dial shown here moves from amber to red as the circuit breaker reaches its safe capacity. Historically, this would mean it would need to be replaced for a larger equivalent unit, which is both expensive, time-consuming and disruptive for customers. The Respond project can help mitigate against this increased fault current and can help defer or avoid the need to replace expensive network equipment. The fault current limiting service could reduce the fault current generated at a customer's premise. When a high fault level is predicted on our network, the equipment at the customer's premises is enabled using new technology being trialled as part of the Respond project. If a network fault then occurs, fault current will flow to the point of fault as before. But the equipment at the customer's premises operates automatically and immediately after the fault is detected. This prevents the customer's equipment from contributing to the fault current on our network. Looking in more detail at the customer premises, you can still see the motor and generator are disconnected, removing the fault current from the network. But the supplies for light, heating and other uses are unaffected by this change. Now that the fault current has been reduced, the circuit breaker can operate safely. The fault is isolated as before and the customers on the right of the diagram go off supply. The rest of the network returns to normal and the circuit breakers at the CHP can be reclosed. All of this, from fault to reclosure, can happen in a matter of minutes. Now, the fault current limiting service is enabled only when the potential fault current or the fault level is high and will only operate when the fault level is high and the fault actually occurs. Customers' equipment may be called on to go off more often than would normally affect a fault for the whole site. So, do you have generation using rotating machines operated in parallel, which is connected to our network? Do you have large motors? Are you willing for this equipment to be disconnected independently of the other supplies on your site? If yes, then a fault current limiting service may be of interest to you. The size, operating voltage and location on the network will affect your contribution to fault current and therefore how suitable your company may be to provide a fault current limiting service. For more information on Respond, please visit our website. If you are interested in taking part in our survey, please register online at enwl.co.uk/respond-survey. The Respond project will run until October 2018, but the survey will take place in autumn this year. Thank you for your time and we look forward to hearing from you.